Hi everybody. The first topic I want to talk about is simplifying radicals. We did talk about this in class. You may already feel comfortable with this. I think it's a review topic from Algebra 1. So if you don't need to see this, you don't need to watch the video. But if you're running into some problems, maybe you can come back and take a look at some of these examples. Okay, and I've kind of laid out the different examples up here on the board that I'm going to be taking a look at. So I want to start out with just the concept of a radical. Remember that a radical is a square root. Okay, so for example, radical 49, I'm just looking at what number multiplies by itself to be 49. If you can get a whole number answer, still give the whole number answer. Okay, nothing has changed there. However, for situations where you would normally have a decimal, where you're going to have to put a radical into your calculator, I don't want you to round these values, okay? I want you to keep these in square root form. Some of these square roots can be simplified, and that's really what we're going to be looking at in this lesson, okay? First of all, knowing what you can do and what you can't do is really important. So if you take a look here, for example, the square root of 4 plus the square root of 9. You might look at that and you might say, hey, maybe I can add the square root of 4 and the square root of 9. 4 plus 9 is 13. Maybe that's equal to 13. And that's a reasonable question to ask, okay? Am I allowed to add numbers under radicals, okay? If you think about it a little bit, a radical, a square root, has to do with something being multiplied by itself to equal another value. So that does kind of suggest that this really has more to do with multiplication and not very much to do with addition, okay? And if you think about this, the square root of 4 is 2, the square root of 9 is 3, okay? 2 plus 3 does not give you the square root, that gives you 5, okay? 5 is not the square root of 13. Okay, 5 is the square root of 25, okay? So a key point here, you cannot add numbers under radicals. This does not work, okay? You also can't subtract numbers under radicals, okay? Very key thing to understand. Now, the follow-up to that, what can you do? Well, it turns out, you can verify this on a calculator. Radicals have to do with something being multiplied by itself to give you a certain value. You can multiply numbers under radicals. That will work, okay? So if you have the square root of 2 times the square root of 3, you can multiply that and you can get the square root of 6. Again, if you're ever not sure if something's legal, stick it in your calculator, see if the decimal equivalent's the same, okay? If it is, what you did was legal, okay? If it doesn't work, then you made up a rule that doesn't work, okay? But you can multiply numbers under radicals and it'll just stay a radical. Division is the reverse of multiplication. You can also divide radicals. So for example, if you have a number under a radical and you have another number under a radical, those two values can be divided, okay? In this particular case, that's some kind of a crazy decimal, that's some kind of a crazy decimal, okay? However, if you divide those two things, you get the square root of 4. Sometimes the radical is actually going to break down and you may actually be able to get a whole number result, okay? So for example, in this problem here, the square root of 12 divided by the square root of 3 actually just ends up equaling 2, which I think is fascinating because you have two infinite decimals, irrational values, that you divide to get a whole number, okay? Again, isn't always going to give you a whole number, but it can give you a whole number, okay? So here's the key. The takeaway from this is that you should be able to take radicals that are decimal values, and in a lot of cases, you're going to be able to break them down, okay? So for example, if I give you the square root of 20, the idea here is it's a decimal. The square root of 16 is 4, the square root of 25 is 5. It's somewhere between 4 and 5, but it's a decimal, okay? If you're going to get a decimal square root, before you circle your final answer, see if it can be broken down using another perfect square. Specifically, what's the largest perfect square that goes into that number? Okay, 20 can be broken up into the square root of 4 times the square root of 5. Okay, we just saw it. Multiply two numbers under radicals and multiply to give you the same value back. Okay, if you can find a number that's a perfect square, so I'm talking 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 25, 49, 64, 100, etc., etc. Find the biggest perfect square that goes into the number times another number. You're replacing it. The square root of 4 is equal to 2. It's being multiplied by the square root of 5. So you can write that as 2 times the square root of 5. The decimal equivalent of this is the same thing as the square root of 20. Okay? May not look real simplified to you, but that is considered to be a better answer, and 2 radical 5 is the simplified version of the square root of 20, okay? If I give you something like the square root of 18, biggest perfect square that goes into 18 is 9, okay? Square root of 9 times the square root of 2, okay? Square root of 9 is 3. Replace that with a 3. It's being multiplied by the square root of 2, so write it as 3 radical 2, okay? Be careful though, you will occasionally see instances where maybe you think you've simplified something and maybe you haven't simplified it all the way. For example, I think in class the other day, we looked at the square root of 72, okay? And a lot of people said 9 is a perfect square that goes into 72. I can write this as square root of 9 times the square root of 8. And then you say, well, that's 3, okay, that's 8. You compare to somebody else, you find out they have a different answer, okay? Why could somebody get a different answer than 3 radical 8 and have it still work out to be the same decimal as the square root of 72? And the answer is pretty simple. You didn't get the biggest perfect square, okay? 8 can actually break up more, okay? There's another perfect square that goes into 8. 4 goes into 8. You can break that up as the square root of 4 times the square root of 2, okay? Now, I didn't lose the 3, okay? It's still being multiplied by all of this out front, okay? 3 stays at 3. Square root of 4 is 2. Remember, everything here is being multiplied, not added. And then you have a radical 2. Okay? A whole number can be multiplied by a whole number. You end up getting 6 radical 2. So check. Just like when you simplify a fraction, you may not get it down all the way. Check what's under your radical. There may be another perfect square that goes into it. If that's the case, you're going to be able to simplify it more. Okay? Now, the fast way to do this is to look for the biggest perfect square that goes into 72. So, for example, 64 is too big, 49 is too big, 36 goes in twice. And if you can break it down as the square root of 36 times the square root of 2, that's 6 radical 2, you're done. You've done it all in one shot. Okay? Also, keep in mind, not every perfect square will break down. Okay? For example, we did 18 earlier. 9 times 2 is how you want to break that down. You break it up into 6 times 3, that's legal, but 6 doesn't break down, 3 doesn't break down, it's not useful. Okay? Don't give me something like square root of 6 times the square root of 3. All right? Something like the square root of 15. 15 breaks up into the square root of 5 and the square root of 3. Neither one of those is a whole number value. If a perfect square doesn't go into the number, it's as simplified as you're going to get. Okay? So the square root of 15, even though it seems like it might break down, isn't going to break down, you're just done. All right? Let's take a look at a few other examples. Remember that I said you can't add, okay? But you may be able to simplify. That's the square root of 4 times the square root of 2. Ends up being 2 radical 2. That's the square root of 3 times the square root of 2. That's 3 radical 2. Okay? If you have the same radical, we're saying here that I have 2 square roots of 2 and 3 square roots of 2. I can add those together. I would have a total of 5 square roots of 2. Okay? Or 5 radical 2. So you can add like terms if they're the same radicals. Now, if you have different radicals, you can only add like terms. So if I have 5 radical 2, and I have 2 radical 2, and I have 3 radical 6, I have a total of 7 square roots of 2, and then separately I have some square roots of 6. Okay? May not look super simplified to you, but that's as far as that's going to simplify. All right? You can't add the square root of 6 and the square root of 2. It's very much like if you had 5x plus 2x plus 3y. You would add the x's together. You wouldn't add the y's together. All right? Back over here. Multiplying. This means 3 times the square root of 2. That means 2 times the square root of 5. Community property says we can multiply those in any order we want. Okay? In this case, you want the whole numbers to multiply by the whole numbers. So 3 gets multiplied by 2. The radicals can be multiplied by the radicals. Okay? And so as a result, 3 times 2 is 6. Square root of 2 times the square root of 5 is the square root of 10. 6 radical 10 is your final answer. 10 does not break down. You're done. Okay? Leave it in that form. Okay? Sometimes when you multiply, you're going to get things that do need to be broken down more. Notice here, if I multiply 2 and 5, I'm going to end up with a 10. Radical 6 times radical 2 is going to give me a square root of 12. 12 breaks down more. Okay? That's going to be 10. It's being multiplied by the square root of 12. That breaks up into the square root of 4 times the square root of 3. Okay? 2 radical 3. So it's going to be 10 times 2 radical 3. And again, you can multiply your whole numbers together. Keep your radical as a radical. 20 radical 3 is going to be the simplified version. So do check. Your radical may break down more, and if it does, you're going to need to take care of that. All right? Final example here, squaring. Remember, when you square something, it's being multiplied by itself. Okay? So this is the same thing as 2 radical 3 times 2 radical 3. Okay? You can multiply the 2's together and get 4. You can multiply the radicals together and get 9. Notice I can take the square root of 9. Okay, that's just 3. It's being multiplied. So this would be 4 times 3, which is just equal to 12. Okay? The other thing you can notice here, if everything's being multiplied, and this does not apply to addition, exponent rules don't apply to addition, but if you remember from Algebra 1, if you have a product or a quotient, that exponent can apply to each value in the product of the quotient. So you can also look at this as being the same thing as 2 squared times the square root of 3 squared. Okay? 2 squared is 4. A square root squared is just going to knock out the square root, and you're going to be left with 3. So this is the same thing as 4 times 3, which is equal to 12. Okay? If you stick this in your calculator, there's absolutely no reason to put this in your calculator, but if you did, make sure you put the parentheses there. If you don't, your calculator is going to give you an incorrect answer. If you type 2 radical 3 squared in your calculator is going to follow the order of operations. It's going to square the 3, the radical 3. Then it's going to multiply by 2, and it's going to give you an answer of 6. Okay, and that is not what you want. You want this whole thing to be squared, and the answer should end up giving you 12. So make sure if you're putting it in your calculator, there's no reason to do that, but if you're trying to check it, if you don't trust yourself, make sure that you're putting it in correctly. And again, keep in mind, if you're doing something and you're not sure if it's legal or not, remember that the decimal equivalent of the original answer should be the same as the decimal equivalent of your final answer. Okay? And so if you try something and you're not sure, see if the decimals match up. If so, you're probably fine. It might need to be simplified more, but at least what you've done is legal. Okay? Again, as always, if you have any questions, feel free to send me an email on Schoology. Feel free to send me an email, any source, or ask me to give you a call, and I'll try to get you caught up with whatever you need help with. Thanks for watching.